Hi, this is Ren. Today I will present my final lab project. Firstly, I will do the small introduction about my project. We all know different colors of the light have the different effects on plant growth. Red light is well known for promoting stem elongation and the flowering, while the blue light promotes the leaves and structure growth. My reason to choose this topic because my friend is growing the green onions in water, which inspired me to explore what the different colors of light can promote the plant growth. My first academic sources explains how plants detect and respond to different wavelengths of light. Plants have the photoreception, such as cytochromes and cryptochromes, that observe specific wavelengths and use them to control growth. This research supports the idea that different colors of light may have the different effects on plant health. Text sources discuss photosynthesis efficiency on the different wavelengths. It shows that red and blue colors are the most strongly absorbed wavelengths, meaning plants usually grow best under these colors. This information helped me support my photo hypothesis. My third source explains the red light is better for growing plants than blue light. It's a study about the cucumber seedling, and people found when the red light ratio was higher than the blue light ratio, cucumber seedling will grow taller and have the higher photosynthesis. This photo is from this article. You can see the different light ratio and their plant head. According to my background researches, my research question is that how do different wavelengths of color affect the growth of the green onion? I predict that green onions under the red light will grow taller than plants under the blue and green light. To step up my experiment, firstly, I buy fresh green onions from Walmart and treat them into the white root sections about 9 centimeters. Then I create 4 groups: red, blue, green, and white light, with 3 green onions in each group. Then I place them in academical practice bottles with 1 inch of water covering the roots. Then I use the colored field to create red, blue, and green light conditions and keep the white light group as my control group. Green onions receive 10 hours of light per day with the lab. You can see the before, during, and after photos. In the before, I treat them into white row section and how I place my experiments. And during the experiments, I found some green onions grew too fast, so I have to put another piece on their top to make them grow up taller. Then after photo, you can see how fast they grew up. I used the standard error analysis for this experiment, and my sample size is the 12 green onions totally. And to reduce bias and confounding variables, to control water amounts, I provide the same amount, about 1 inch of water daily. To control light intensity, I place lab at the same height above on bottom. And it is my data button. You can see the full outline is the data from day 0 to the day 7, and the total growth means the final head minus the day 0 head. And my own measurements use the centimeter as the unit. At the left side corner, you can see that group has the average data and the standard deviation data. And this is my standard arrow and Z graphic. You can see the bullet has the largest error bar and the white line almost no error bars. Overall, the bullet produce the most good, and then the red, then green, and the white. The bullet also showed the largest reversion because it has the largest error bar. White allied has a most novel version because it means the control group grew very consistently. But the error bars for red, blue, and green overlap slightly. The difference between these groups may not be very statistically significant. In conclusion, my original hypothesis was refuted. I predicted red light would grow the most, but the result showed the blue light produced the greatest growth in hydroponic green onion. It shows that blue light is the most effective light color than the red and green light in promoting green onions growth. If I repeat this experiment, I would make some improvements. Firstly, I will improve light isolation. This time, some color light may have leaked between groups. So next time, I would use some separate box to keep each group completely isolated. Second, I will increase sample size. I only used 3 green onions per group, which made the very large error bar. So next time I would use 5-10 green onions per group to reduce reversion and make the result more statistically reliable. Here are my 3 references. Thank you for watching my presentation.